In the last video, we talked about the first derivative test, which let us test whether a critical point was a local maximum or a local minimum, or whether it was neither. I said that there was a second test that we could use, and this is called the second derivative test. Isn't that handy? Let's take a look at it, and then we'll be able to talk about when you can use one or the other, because they both have pluses and minuses. All right, so the second derivative test means that first thing we need to do is we need to calculate the second derivative of the function. Okay, so let's go back to this example we've been dealing with. So f of x is equal to 3x to the fifth minus 5x cubed. And so f prime of x was equal to 15 times x to the fourth minus 15x squared. So what is the second derivative of x? Well, we're just going to keep on using our power rule. So that is equal to 60 times x to the third power minus 30 times x. All right. And so remember, in the first derivative test, we thought about the intervals between the critical points. And so the intervals between the critical points we're using to figure out if the function was increasing or decreasing over those intervals. This time, we're just going to apply the second derivative to the critical points themselves. So our 3 points were x is equal to 0, x is equal to -1, and x is equal to +1. All right, and so we're just going to plug these values into the function. So the second derivative of 0 is equal to 60 times 0 cubed minus 30 times 0 cubed, which is just 0. If we plug in -1, -1 cubed is -1. So this is 60. -1 is equal to -1 times 60 minus 30 times -1, which is, oh my gosh, -60 plus 30, which is equal to -30. And finally, when x was equal to +1, the second derivative evaluated at 1 was 60 minus 30, which is equal to +30. All right, so let's go back and think about our derivative behavior reference sheet and remember what we know about the second derivative. So if the second derivative is positive, then we've got a concave up function. If the second derivative is negative, then we've got a concave down function. Okay, and so here we know that the second derivative is negative. So this is a concave down function. So around -1, it's got to be part of this sad shape. Okay, so I know that it's a turning point, and if it's got this frowny shape, then that means it's negative on both sides. So I can tell right off the bat that that is a local maximum. Over here, I know that the second derivative is positive, so the function is concave up at that point. And so the function is concave up at that point. I know that it's a local minimum. All right, so that's a handy thing. So the second derivative test says that you calculate the second derivative and apply it to each of the critical points. If you get a positive answer, you know it's a local minimum. If you get a negative response, then you know it's a local maximum. Here's one of the downsides of the second derivative test. If the second derivative is equal to 0, I don't know a thing. It could be a maximum, it could be a minimum, or it could be, in this case, it's neither. Okay, either one of those things can happen when the second derivative is equal to 0. So the test is inconclusive if the value is equal to 0. So as I said before, the second derivative test has some pluses and minuses. I think one big positive is that if the second derivative is easy to calculate, it's a lot easier to kind of just calculate the values just plugging -1 and +1 into the function. What we had to do with the first derivative test is stick -1 into that first derivative, and I had the calculator do it because I didn't want to do that myself. So it's less hassle when it works. And the second derivative test works when the second derivative is easy to calculate. If the second derivative were hard to calculate, if I needed to do a lot of work with a quotient rule or something like that, then it's probably a lot less effort to just stick with the first derivative test because I've already calculated the first derivative. And the other downside of the second derivative test is that if you get 0 as an answer, you don't have an answer. So you've got to go back to the first derivative test and use that. The first derivative test will always work for you. Okay, so those are the two tests, the first derivative test and the second derivative test. Which one you use to calculate these is really up to you. So you can practice going back and forth between them. You might find that sometimes one is better than the other. You might find sometimes the other one is better, or you might find that you always like using one of them, and any one of those decisions is fine.